To find the real roots, or zeros, of a quadratic function in vertex form, we solve the following equation. A times x minus h squared plus k, this is our standard vertex form, equals 0. So then if we move this k over to the other side by subtracting k from both sides, and then we divide this a onto the other side, and then we take the square root of both sides, we get x minus h equals plus or minus the square root of negative k over a. So when we move the h over, we get x equals h minus the square root of negative k over a, or x equals h plus the square root of negative k over a. The real roots or zeros of a quadratic function in vertex form are given by x equals h plus or minus the square root of negative k over a. Now, if we focus just on this portion underneath the radical, we have three possible scenarios. If this amount is less than 0, then there are no real roots because the square root of a negative is undefined. If this number here equals 0, that means the square root of 0 is 0 and there's one real root. So there's going to be 1, 0. And if this amount, negative k over a, is greater than 0, the square root of a positive number is a positive number. Therefore, there will be two real roots. There will be two zeros. All right, so here's two examples of where there's going to be no real zeros, no roots at all, when negative k over a is less than 0. So in this case, a is positive and k is positive, and because there's a negative sign built in here, if they're both positive numbers, that means that this number will remain negative. So here's an example of what that might look like. And here, if they're both negative, so if you have negative k value and a negative a value, those cancel, but we'll still be left with one negative sign. Therefore, this is an example of what that would look like. It would be downward facing, and our k value is going to be below the x-axis, and there won't be any points where the graph crosses the x-axis. All right, here's some examples where k equals 0. So if a is greater than 0 and k equals 0, then we're going to have one real 0 right at h. In this diagram, a is less than 0, so the parabola faces down, and k equals 0, so we have one real 0 also right at the x value of h. Here are two examples where there are two real zeros, and that would be when negative k over a is greater than 0, so a positive number. So in this situation, a is positive, but k is negative, and that negative sign cancels out with this negative sign, creating two real zeros, and so we have one at z1 and z2, and we still have our vertex at h, k. In this example, a is less than 0, so that's what cancels out that negative sign, and we have k is greater than 0. And so here's our vertex, downward facing parabola with two zeros. Exercise A. Determine the x-intercepts for the quadratic function here. F of x equals negative 2 times x minus 7 squared plus 2. So all we have to do is set this whole thing equal to 0. Here's our quadratic equation. We'll move this 2 over, subtract 2 from both sides, equals negative 2. We'll divide both sides by negative 2. That gives us x minus 7 squared equals 1. So that means x minus 7 equals positive or negative square root of 1, which is 1. So x equals 7 plus 1 or 7 minus 1. So 8 and 6 are the two roots. So because these roots are 8 and 6, those are the x coordinates. And of course the y coordinates will be at 0 because these are points where the graph intercept the x-axis. Exercise B. Determine the x-intercepts for the quadratic function. G of x equals 3 times x plus 6 squared plus 9. So all we do is set this quadratic equation equal to 0. That gives us 3 times x plus 6 squared equals negative 9. Divide both sides by 3, and we have a negative number over here. So if we try to take the square root of both sides, we can't, because you can't take the square root of a negative number. Therefore, there are no zeros.